want to provide the best blueprint, architecture, configuration, operational best practice. You're going to hear me repeat this frequently. And our goal is that for any type of unplanned failure, it could be a node failure, instance failure, corruption, database failure, anything we should be able to tolerate. And for planned maintenance, we want to provide you a solution that allows you to do online maintenance, online patching, and rolling upgrade. So what's different with Exadata? Before, we provided all these white papers and MOS notes, and hopefully a lot of you have seen some of our white papers. Today, with Exadata, we can incorporate a lot of these best practices into the engineer system itself. So we can configure the firmware, the system, the database, the grid infrastructure with our best practices. We can provide tools and MA practices specific to Exadata. It's really our strategic platform for Exadata, for MAA today. We made up this little pyramid, and it's important to me to convey this because you start with your business requirements. What does your business need to achieve your HA requirements? You know, recovery time objective, recovery point objective, performance requirements. Then you build the architecture that will meet those requirements. Okay. Then you put in the configuration best practices of MA and Exadata to make it run really well and efficient. That was the topic of yesterday's session that you can download. And then what's also key is the operational best practices, to maintain it, administer it, keep it as stable, maximize the stability and availability. And that's the topic of today's presentation. So let's delve into this. So there's a lot of topics on this presentation. And I want to just emphasize, I want to highlight the key points here. But enable you to be a better administrator, enable you so you understand Exadata and maximum availability and maximum stability. There's an appendix at the end of this presentation that have links to other deep dive documentation or my Oracle support notes. So this is the starter, the enabler, and I hope you can download this presentation afterwards and go forth with it. So let's start smart. And what does that mean? Well, you just bought Exadata or you have existing Exadata, and you want to move application XYZ to Exadata. Okay? So what we want you to do is make sure you do the initial sizing with your pre-sales and sales consultant team, or your consultant teams. And really evaluate how much CPU, how much memory, how much I/O are you using during average and peak loads? Are you calculating your growth going forward? Are you including redundancy, the level of redundancy, right? I've seen a lot of systems where the customer's consolidating a lot of applications onto Exadata, but each application needs 30 gigs of SGA. And you put 10 of them, you're exceeding the amount of memory we have for maybe X32, for example. You want to start smart, size correctly, and then leverage our great engineer system and the high bandwidth and the smart capabilities. But you don't want to subscribe all the resources and not calculate the amount of growth that you need to accommodate. After that, it becomes pretty easy. Deployment, we now have a Java-based deployment tool. It's a wizard. Hub sets to the network, the system, the whole configuration. It asks you about ASR, Oracle Configuration Manager, EM, agents, helps pre-configure that for you, right? The output of that is a configuration file. You feed it into our one command, and then it deploys the system for you, right? It sets up the software, sets up the disk group, the grid infrastructure, the real application clusters with the MA configuration and best practices that we want you guys to start with, right? So within unwrapping the box, right? you can essentially have an up and running real application cluster database on Exadata with our best practices in 3 to 5 days. PayPal had a 4 interact system running their mission critical application. And we were very involved with PayPal. And they deployed the 4 racks within those 5 days. Okay? Had a running database. Okay. And the key is, once you have that deployment, you have our configuration best practice, a great starter kit, right? And you just jump ahead of most people on non-Exadata. So start smart. The main thing is just leverage your pre-sale sales consultant. Use the sizing tools. We put a lot of input there, and it has helped avoid a lot of problems initially. Next step, migrate and optimize. For Exadata, we have a lot of great capabilities with the smart flash cache, smart storage, the write-back flash now in this release. But if you're coming from a data warehouse application, you may have to evaluate how Exadata does a paradigm shift for you, right? A technology shift for you. In a data warehouse application, you may need to reevaluate if you need all those indexes, right? Don't just do a straight migration. Do optimize right now, right, when you do the migration. The other thing is that if you're coming from a data warehouse application, and you have big fat data that you're only reading from, you may take advantage of the columnar compression, right? And we've seen customers reap the benefits of shrinking their storage requirements for the fat tables from 5x, 10x, and in some cases 70x. So this is a big benefit, not only for storage, but for I/O, for your performance. So take advantage and reevaluate, especially for data warehouse, if you need to do some changes. The second thing is, if you're coming from 9i, 10G, you have all these fancy init.org parameters and underscore parameters and hints. Throw that out. We have Exadata here, and we work on so many different workloads, and we work with the real-world performance team and the performance experts, and we believe we have a great template default setting, right? Migrate your application without that baggage, without the hints, without your old and in-house parameters, and evaluate the performance. We get a lot of good stories about migrating right off the bat. We get better response time. We get 10x better reporting query times. All these great benefits out of the box. Evaluate if you need those hints. Check if you need to change your object layout. This is mostly for data warehouse, but the init.org applies for all applications. Now that you have migrated or understood what needs to be changed, what kind of techniques are available to you? Okay. There's really 2 types. There's physical migration and logical migration. And I'm going to simplify this right now. For OLTP applications that are running sufficiently, you probably already tuned and configured this. You have the right amount of indexes. You have the correct access paths. You probably could do a physical migration of that, right? And leverage things like standby database, transportable tables. For data warehouse, again, you may have to reevaluate about using columnar compression. Reevaluate if you need all those indexes. It's sometimes good to unload and load back in a logical way of migration. Probably makes a lot of sense. And you can reap the benefits of a more optimized system on Exadata. Data pump or a hybrid of data pump and insert as select. And everyone asks me, so that's great. You know, I think I need to do physical, or I think I need to do logical. How do I get low downtime? How can I migrate my system from IBM, HP, or any operating system? How do I migrate my system from 9i, 10G, 11G to Exadata running Linux or Solaris x86 on 11.202 or 11.203. Okay. We have load downtime options, right? And depending on those variables, say for OLTP, you can use a physical migration method. You can use data guard if the versions and the operating system is compatible. That's easy. You can just switch over, you're up and running in seconds and minutes. That's what PayPal did when they migrated their 10G database to Exadata on Linux. They did a conversion of a switchover. Okay. Or if you had to do a logical migration, you could eventually use Go and Gate. I mean, that's just an instantiation. You use Go and Gate to keep it in sync, and then migrate your application and your client to the new target. So we do have these low downtime options. We have different tricks using physical standby, transit logical, or data guard. There's this, at the appendix, there's a kind of migration strategy presentation with links to other MOS notes for each of these different techniques. But this kind of highlights the summary. So you start it smart, you size right, you determine what application you're going to migrate or consolidate onto Exadata. You migrate while optimizing and pick the right strategy. The next thing is you want to leverage exachk, right? That's one thing that every Exadata uses. What is this? This is our comprehensive health check, hardware, software, configuration best practices. We meet in development, we meet at least a couple times a week with support, with our performance engineers, with our different development engineers, and we brainstorm on best practices, critical issues. And our goal is to make sure you, as the audience, as our customer, reap the benefits of those discussions. So we build best practices after we validate. I want to stress that we validate. You don't just, okay, this sounds like a good best practice, is that it? That we validate and make sure what the impact is. And then we kind of put it into this mechanism where we publish the best practice, and if you have time, you can read all these pages about our best practices, and then consume it into this tool. Let me give you an example. So, it's a nice, simple HTML report. You look at the summary, okay, this is my X28 system, 2-node, 14 cell, 3 switches. Yeah, this is my system. Yeah, things pass, that's cool, but there's something that failed. That's where I want to focus my time on. I want to focus the time on things that failed, that's alerting, and the MA scorecard. This is our mechanism to alert you and hopefully avoid any stability issues going forward. So for each category, database server, storage server, cluster, here's the major alerts. There's failures, warnings. There's a different category about passing. You can look at that, but you want to focus on this area, those areas. So as a new administrator of Exadata, for example, you say, whoa, thanks for the summary. Okay, what does this mean? I'm kind of new to this. What does this mean? So I'm going to click on the view, right? And you get more information. Okay? And what's our goal? We want to tell you, describe the recommendation, give you the impact analysis. If we tell you to change something, you want to know what we believe the impact will be. Okay? And then, of course, we want to give you the directions and steps to make that change. Okay, so we're trying to simplify the administration. We want to highlight the best practices. This is something we added, I think, 1 or 2 releases ago of exachk. There's times when you're running your critical applications using our clusterware, using ASM, using database. There's times that there's issues. It's hard to believe. Sometimes there's issues, and we find these issues in this war room. We talk about, we get these fixes in, and We may have workarounds, or it may just need a software fix. How do we tell everyone here? Well, we support, does a pretty good job of sending these alerts out. But we also consume these critical issues into exachk. So it says here, because we know what release you're running, because we just did a holistic evaluation of your system, you're exposed to this issue, unfortunately. So, oh my goodness, this sounds kind of serious. What do I do? Then you look at the recommendation, look at the impact. In some cases, you may just have to work it around. In some cases, it's not even relevant to you because you don't use this type of access path. This is not a, there may be an issue with bitmap indexes, and you don't use any bitmap indexes. But you're aware of this issue, and you can make a judgment call that this is applicable to you and how quickly you should act on it. Okay. This is something that we worked hard on, and this is our mini, or our MA review, our automated review. Now, I talked a lot about putting our MA configuration best practices into Exadata, the engineer system. There's certain settings, certain configurations that we can't just put in by default, right? Because you may not have data guard yet. We have to evaluate what kind of clients you have. Are you using services? Some of our corruption protection settings may have some performance impact for some applications. So we can't put those in as default. So in this case, we do a evaluation of your system and say, what are your exposures in repair and stability from an MA perspective? And it highlights are you well-tuned for computer failure, for corruption, for site and database failures? And highlights the configuration things that we recommend and, again, the impact analysis. So this is something that we used to go to a customer site and do this kind of review, and we said, well, let's standardize it, just automate it. And this is part of exachk today. This is something recent as well. To be honest, we had some challenges with customers upgrading from 11.201 to 11.202. Now, generic challenges. And of course, Exadata customers face those same challenges. Right off, immediately during the war room, we had to write a step-by-step list of instructions how to do this. And we told ourselves, let's avoid this problem for 11.203. Let's, first of all, make it easier, and make the process as easy as possible. But even with that, there's a lot of pre-checks that needs to be done. We added those pre-checks and post-checks into exachk. Every time we hear a big 11.203 upgrade, we always want to know what the experience is. If it failed, we want to know, and then incorporate any additional checks that needs to be done. So again, we're working hard to make sure all customers get a good Oracle experience, but Exadata has both the hardware, software, and configuration. We want to make sure all of that is taken care of when you work with Exadata and when you upgrade different components. So, it's a no-brainer. You've got to use exachk. It's great. We're working on the performance to speed it up a little bit, but it is a very comprehensive check. But exachk is a health check. It's not a real-time monitoring component. And that comes into the next topic. You need, Exadata is engineered to tolerate different failures. So disk failures, switch failures, node failures. The application will keep running because we can fail over to different components. We have the software that will allow you to keep running. However, when things fail, or when you run out of space, or you come close to running out of space, you want to take care of those things so you remain highly resilient, right? You remain more stable. Okay, and that's where the real-time monitoring comes in, from ASR, configuration management, and definitely Enterprise 12c. I'll talk a little bit about that now. When different component fails, and disk fails, log the SR for you, and analyze the SR, and get that field engineer out there as soon as possible to replace it. Again, we'll tolerate that failure, but let's get back to full resiliency, full performance. Okay? I've talked to customers that doing a post-mortem, and before they had problems, they had 4 disks that was bad. It was bad for the last 9 months at different time periods. And they just didn't, I didn't see that alert. And it was because they didn't have ASR. So it really kind of catches the component failures until, you don't want a lot of component failures be undetected. That could cause problems, of course. Oracle configuration management is something that Oracle, and I'll talk a little bit about this Platinum service is moving into. We do want to know you guys more. We want to know how you're configuring this specifically for your application, for your consolidation, for OLTP and data warehouse. You may say we're nosy, but the goal is really so we can tailor our best practices back to you. And this is essential to give you that additional service from a best practice perspective. EM12C really changed my mindset quite a bit. I was more, my team is more like down and dirty, on the system, and EM was a little bit on the peripheral for the most part. But when we got into the engineer systems, when they built EM specifically to enhance and understand Exadata, I became a believer. I'm Oracle, so that's a big thing. You still need EM to monitor your database and your application, to understand system load, active sessions, what's busy, the memory, the I/O resources. It does the generic stuff, right, that you need. But you also want a monitoring agent that understands the whole engineer system. That you have 8 nodes, 14 cells, 3 switches, that you can glance at it and see if any component is failing, right, or underperforming. And then you want the combination where you can look at something like, here's my different workloads, which one's eating, consuming the I/O, how can I delve into the database and see for the data warehouse service, which query is consuming the most I/O. That kind of from high level to low level troubleshooting. And finally, Platinum service is a free service for Exadata customers. It encompasses a lot of the best practices that I just talked about. ASR, OCM, EM12C. It gives you another set of eyes within Oracle to monitor and manage your system to aid in your administration of your Exadata system. It does have other services that come with it, like patching and monitoring and restoration, and restoration SLAs. So this is a value add for you, and something that you may want to consider, especially if you're new to Exadata, right? New to administration of Exadata. This may fit. If you're an expert Exadata administrator, and some of you may be, and you already got this down, maybe it's not needed, but it is a value add. Okay, so we covered monitoring, and you can see there's the pillars of monitoring with hardware component failures, with configuration, with EM12C doing the whole stack, and then finally Platinum. What I see a lot, and it's less now, I would say, is testing. How can you avoid adding an application change or a database change, upgrading to a new software, and avoiding some unpredictability of that change? Well, it's to test best practices. First and foremost, you got to understand what your requirements are. For this application, for PayPal, they need to achieve 30,000 executions a second less than 200 milliseconds. They have those requirements, right? You need to understand your requirements. You need to know that if I fail any component, I need this type of brownout or no downtime. So you have those requirements understood. You understand your functionality, your behavior, what you expect from your behavior. Okay? And any change, I believe, you should have some idea of what the fallback is. So those are the test requirements and goals. Next, what test resources are needed and what test approach is best. So this is no different from Exadata or non-Exadata. The best test resources is something that is very similar or identical to the production system. And why is that the case? Well, you can do a full evaluation. You can do a performance evaluation. You can do an HA validation. And you can catch the most problems and do problem avoidance with something that's identical. So if you do a test cycle before you make a change of a month, you catch 3 problems. You get those problems fixed before you apply on the primary. You avoided 3 problems on your primary. That's great problem avoidance. Okay. Now a smaller Exadata is great too. I mean, it allows you to evaluate a lot of this. Maybe you can't do a full performance test, right? But it's very reasonable to do the software upgrade, the functional test, some performance, some HA. Even in non-Exadata, it's not ideal. Again, the ideal is the identical system. But at least you can do some software changes and some functionality testing, but you can't leverage any Exadata capabilities. So you can see where we're hoping customers will move toward. A lot of our mission-critical customers definitely go to the identical system, or at least a smaller Exadata system. The test approach, any change could be a risk. And that's why the beauty of engineered systems, when we make a change to the firmware, we go through a full evaluation. Why should it be different when you make a change in your environment, when you do a database or application change? You want to have a test system that you can trust, clone it from the production, use real application testing so you can simulate something very similar to your workload. Do the change, get it automated, understand fallback, do your functional performance HA testing. Once you got it down and got all the fixes in, hey, if you have a standby, apply on the standby. No risk, big benefit. Okay. We have seen customers apply on the standby, fortunately found some issues, but again, those issues are hidden from the primary. Get those issues fixed before applying to the primary. You have a choice to apply on the primary or just do a switch over and eventually apply it to the old primary. Okay. We do a lot of HA testing in-house already, but we don't have your specific app. So it'd be good for you to do a minimum set of HA testing where you're sure that your application failed over when you have a node failure or a database failure. Right? That's probably the key thing. We're pulling switches and pulling out disks already, and we're evaluating a lot of that. So the redundancy is there, the capability is there, but we don't have your specific app. So I always recommend some level of application HA testing. DataGuard has saved so many customers from corruptions, from database failures, reducing the downtime for your application. But obviously, if you don't practice, don't use it, you'd be afraid to use it. Right? We have, our government uses DataGuard quite a bit. They have a lot of Exadatas. And when they have a problem with the primary, they switch over. Right? Or they fail over. They troubleshoot on the primary, old primary, I'm sorry, but they have their application up and running in minutes or seconds. But you need to practice. Okay. And the last section is patching. Check my time here. Oh, okay. So patching and plant maintenance is a big topic. I think Doug Utsick from my team and Jim Buscuzzi presented, I think, Monday on this topic. And I have references to those best practices. But what I want to tell you is we have a planning guide. We describe in the planning guide every component of Exadata, both hardware and software, and what the expectation is from a maintenance perspective. So you have a good idea of what needs to be maintained, right? And what options we have to apply those changes. It can be rolling or non-rolling, and what the impact of those things are. Okay? Let me go through this through examples. Do I want you to patch right when something comes out? No. I mean, who does that from a mission critical perspective? There may be some critical issues that you may need higher attention. You go through your test cycle, you have from your company something that's reasonable, and we describe what we recommend as a good frequency, right? And the different components, and if we have, for all these cases, we have like a zero downtime or rolling perspective solution. I think everyone knows about 888.2.8.1. Does anyone, how many knows about this note? I figured this is probably the most popular note. It tells you what is supported, new announcements from a software perspective, and for every component, what the current release is. The critical issues list is what feeds into exachk a little bit, but if you want the latest and greatest, this note tells you the critical issues within database and Exadata that may affect you, and the description of those issues. From a high level, our goal is to simplify maintenance for you. And if you talk to database and Exadata old-timers, will know that from the V2 or even V1 day to today, maintenance have improved, especially like cell patching, DB patching. We're working quite a bit to automate. The rolling upgrade option is there for you, right, for zero low downtime. It does take more operator time, more investment in work. But it's there. We're trying to automate as much as possible, have the checks there. Non-rolling has downtime, like an hour to patch all the cells, but the operator time is less. That's pretty clear. And we're seeing more and more of our patch cycles being done on the standby. That's another use of the standby. The standby is usually not idle. You can use it for reporting, testing, backups, but also for these planned maintenance activities. Okay? So once again, we have a whole appendix full of documentation. Hopefully I'll highlight the key points, and I'd like to pass it to Andy.
Thank you, Lawrence. I'm Andy Coleman. I want to thank everybody for coming this morning. I'm here to talk about what we've seen at exachk from an operational perspective from all the Exadata customers that we've worked with in the past. If I can get that slide. There we go. So a quick note on exachk and what we are. We're an Oracle-centric consulting firm. We're a platinum partner. We're based in Dallas. We've been around for about 8 years now. Back in 2010, we purchased our first Exadata V2 after working on it with a customer. So we decided to buy one for our lab to do proof of concepts and see how it works, figure out how to break it and how to fix it so that we can help customers. About a year later, Oracle announced the X2. We needed to get one of those. So we added one of those to our lab, and now we're scrambling to procure an X3. Over the last 2.5 years, we've done approximately 100 Exadata implementations for customers. Personally, I've worked on about 50 or 60 boxes, separate racks for about 30 customers. So I've got a pretty wide range covering patching, installation, migration, the whole gamut. So what we do is we help customers from the very beginning, pre-sales, finding out if Exadata works for them, all the way through installation, support, managed service, all that good stuff. So that's enough marketing. But on to the good stuff. One of the biggest challenges that most of our customers run into, and one of the biggest talking points that everybody wants to talk about on Exadata, is the patching. It's as hard as you want to make it, basically. I'm going to say a few things over and over again. If you keep things simple and you use common sense, then these things are going to do great for you. If you make it very difficult, then you could be making life difficult for yourself. But if you follow the general best practices for running any kind of system, you're going to see great results on your Exadata. So when it comes to patching, do the same thing. If you have a dev test box and you're going to patch it with a rolling method if that's what you're going to do in production. You don't necessarily want to see something new because you're doing a completely different patch method because you can't take production down. And honestly, most of the time these days, we've had more trouble getting outages on production or on dev test systems than on production. With 24-hour development cycles, it seems like we can touch production on a weekend. Development, not so much. So we've been doing a lot more rolling patches for customers. Something like this, where you use the same methods, if you do it on dev test, it's going to give you a good idea for what your maintenance window should look like when you hit production. We had a customer that we were going through cell patch, OS upgrade, database upgrade, grid infrastructure upgrade. We expected it to take about 8 hours. We did a rolling patch. We got it done in 4. So it ended up giving us a lot better gauge on what we should be looking for when it comes to what to do on production. And we had a better idea of what to take to the business. One of the other really good things that Lawrence mentioned is standby first patching. If you're not using it, it's great to use. You don't have to take both sides of your rack down unless you're doing a database upgrade. There are even ways around that if you're using logical standby and a few other different methods. But we've seen really good results with take the standby down, patch the cells, bring it up. You can switch over to it, or you can take production down or do a rolling patch on there. And it really cuts down your maintenance window and cuts down on any downtime that you might have. So Oracle's done a really good job of making sure that every single bundle patch, quarterly database patch, cell patch, InfiniBand switch, all of those are standby first patch apply. So you know that when you get one of those, you're going to be able to do it that way. So the next thing that I want to talk about really quick are the different methods that Oracle gives you to get alerts and to monitor your systems. So it seems like there are a whole bunch of different things. There's ASR, there's OEM, there's the internal mechanism within CellServe on the storage servers for how you can monitor these things. They all sort of complement each other and they've all got their own good traits. So what you might get from one, you may not get from another, but there's also some overlap. So when it comes to something like ASR, it's great for compute node hardware failures, things like that. Any kind of hardware failure that you're going to see, you're going to get a notification from ASR. It's going to open a service request, it's going to get the ball rolling. You may have a log that you have to upload to Oracle support to get it moving, but our experience has been that it's very quick. When ASR, something breaks, you just upload a log if you need to, or an ILOM snapshot, and they're moving really, really quickly to get everything going. When it comes to there's some overlap with CellServe and ASR within the cell software. The cell software doesn't necessarily know about what's going on at the database level, but if you were to lose a hard disk or a flash disk, you're going to get a notification from ASR, you'll get a notification from the cell software. Personally, I'd rather have 2 notifications than none. Most of our customers are running all 3 of these components together. We've got a couple that don't have ASR yet. They're still in the process of finding a place to put it. The first thing that we always set up on a new system is CellServe monitoring. Every installation we require that gets done, because that's the really critical piece. You'll know if a compute node goes down because you'll probably have somebody complaining pretty quickly. But when it comes to a hard disk, if you don't have any kind of monitoring going on, you might not know. We've had customers in the past that, like Lawrence said, they've lost a few disks. System stayed up, that's great. But still, you're losing capacity, you're losing performance, because one of the keys of Exadata is spreading everything across as many disks as you can. If you lose 5 or 6 disks over the course of a year and you never replace any, then you're running in a degraded state and you don't even know it. So when it comes to Enterprise Manager, it's the traditional Enterprise Manager alerts. That's the same things that you've always received with your database downtime, server reboots, resource consumption. If you find out that one of your database servers is using too much CPU, you can get an alert. It's fully customizable to whatever you want, metric-wise, alert-wise, however you want to receive those. It overlaps a little bit with the self-serve software, and that if you're running OEM 12c, which I hope most of you are if you have an Exadata because it's awesome, it's really easy to configure, and once you configure that plugin, it will set up, if you configure the metrics, to send you notifications if an InfiniBand switch has a problem. If you run into any cell failures or things like that. It's very, very good about keeping you up to date with what's going on. So I've got a couple of examples of alerts that we've seen. Some of these are from our system, a couple of them are from a customer. But I've got one of these up here that this is a SQL quarantine. Let me note that this very rarely happens. Basically what happens is there's too much offloading going on in a cell and it shuts off the storage server features and it kicks it back. The performance is a little bit slow, but you have the ability to go into cell serve and drop that quarantine if you need to. This came up during our Exadata conference back in August. Tanel Potter was sitting in the back of somebody's session just hammering away at our Exadata, and he was trying to figure out how to make this happen. So he was going out of his way to make it happen. But what you get as an administrator, if you have these alerts configured, is you get sent a notification. So you already know before the user comes to you and says, hey, this is running really slow. You can say, well, what were you doing with that SQL? It gives you the SQL ID and tells you exactly what you might need to do. So these are really rare. One of the other things that we've gotten that's really rare also, we've done it to prove sort of to customers and things like that. We'll go in and do a kill 9 on cell serve to simulate a crash. There's a service process on the Exadata that starts it back up, and when it does that, it sends the administrators an email. It says, hello, cell serve died. Here's the error that you might have received. By the way, I started it up. And oh, by the way, I've also created an incident package. It's right here. You can upload it to Oracle support if you need to. So it's very, very resilient, and it knows exactly how to go through all these things, and it points you in the right direction. When it comes to hardware failures, this is another alert from CellServe. This was a hard disk that we lost on one of our V2 cells a couple of weeks ago. If you've got an Exadata, you've probably seen one of these before. Disks die. It's a part of life. DBAs weren't used to seeing it before. Now they know because they see the storage. The storage guys always just lied before and said, oh, no, nothing ever goes out. Everything's fine. We've all heard that. So you get a nice little pretty picture that says, here's the disk that died. And if you don't know, it's the one with the red ring around it. You walk over, it's got an orange light. You unplug it. You plug the other one in. You get another email. Looks very similar. Says, alert cleared. You've got a green ring around it. And everything's good. It's building everything back up. And oh, by the way, the system never went down. So it's really nice to see this kind of stuff. You can get these alerts through email. You can send them through SNMP to your OEM server if you want to, or anything else that you might have. We've seen these alerts for things like flashcards, InfiniBand ports, if we unplug a switch, something like that. Power supplies. Our building's a little unreliable. Sometimes we've had a power go down on one side and stayed up on the other, and so we get some alerts on the power supplies. But it's really useful. And as far as the same type of alert as that last one where we got an email from CellServe, here's the overlap. This is straight pulled out of an SR for a customer that we had on one of their storage servers on an X2 half rack, that they lost one of the operating system disks in one of their storage servers. So not only was it just one of their regular ASM disks, it was one of the 2 operating system disks. ASR automatically sent up an alert, created a service request, sent an email to the administrator and said, oh, by the way, one of your disks died. Here's what you need to do. We uploaded the SunDiag output to Oracle support, and within 45 minutes we had a field service task already assigned, and we had a Sun tech calling us, asking us where we should take the work. So we've had really, really good response through hardware failures with ASR. From Oracle support, they probably don't want to hear it, but honestly, we've had a little bit better believability factor, if you will, from the support people when ASR says that something's dead. If you remember, if you have a V2 and something died a while back before anybody was really implementing it, you'd have to go through a couple of logs. Send this, send that. Now they've got it all automated, so if something goes out, you upload one script, and they believe you immediately. And if it's ASR, it's even better than that. So I definitely can't recommend this stuff high enough. Because using something like OEM, using ASR, using the built-in alerting features that Oracle gives you, it combines to give you the most protection that you can from managing these systems. Question?
Yeah, there's a few items that ASR doesn't cover, and what do you do about that? And an example would be the batteries.
So the question was, there are a couple of things that ASR might not cover, like the batteries. In the RAID controllers, I take it?
Yeah.
Yes. So in the V2s, if you haven't had your batteries replaced, you probably need to on your RAID controllers. Your I/O is probably a little bit slow. You should receive an alert from CellServe when the RAID controller battery gets down to a degraded state. You'll receive it from the cells. They do a quarterly check, and you'll receive an email once every 3 months that will tell you it's down, and then it'll charge it back up. The answer to your question for how you catch this stuff, run the exachk script. If you run exachk, it will tell you. You can configure through Enterprise Manager for it to run the exachk script once a month, once a week, however often you might want to, and it will let you know. So what Lawrence said about running exachk regularly, on every system before we patch, we run exachk a week early. Before we're going to patch it, we run exachk to make sure we don't have any surprises that are going to come up before we apply the patch. Because that way we need to know if a RAID controller is out, if you're missing any disks, if one of your flash modules has gone awry and you never noticed. So it's really good to run that stuff and find out before you're in the middle of it and you're patching the system and you've taken it down, you're updating firmware and you realize that something might be degraded. So to wrap up real quick, and then we'll have some time for questions, the key that I can't stress enough is Exadata is still Linux. It's Oracle database. You might be running Solaris if that's what you're inclined to. But it's still just an OS. It's a bunch of boxes. Yes, it has some special features. Yes, the storage servers are a little bit different. But you administer the compute nodes and the database servers exactly like you would any traditional database system. So if you need to make some modifications, you can. I wouldn't recommend going too far with it. But it's still it's an Oracle database. It's not running any special software from what you would download for the 11.203 patch set. None of the special features are really in the database as opposed to if you built your own rack. All the special stuff happens down at the storage level. And use common sense. You wouldn't just with a regular 11.203 4-node rack just go in and say, well, we're going to patch it this weekend, it's Friday, let's do it, it's fun. Just because it's Exadata and it's an engineered system, and yes, it can be easier to administer, you don't do that either. You take time, you plan out what you're going to do, and if you go that route, then you'll be most likely seeing success. And if you take an iterative approach that you go through every time, you follow the same steps, you're going to know what to do if something goes wrong, because you've probably seen it before. And it's not a black box. You do still have to patch it. When I was in Doug Utzig's session on Monday, he said that he had heard from customers back in the V2 days that people were saying, oh, it's Exadata, you don't have to patch it. You never do, it's fine, it'll just run. And it does. We've had customers that have gone 2 years on their V2 systems and never patched. And then they hit a bug. And the answer is, well, you need to patch. So it is something that still needs your standard maintenance. You should be patching your regular systems every 6 months anyway. It's one of those things that we recommend quarterly if you can, 6 months if you need to, but it's really as easy as you want to make it. So with that, I guess we can open it up for any questions.
Thanks, Andy. I just want to really quickly say, hey, for the maximum embedded building stability, start with the architecture, configuration best practices, and all the things that Andy and myself mentioned today, the operational best practices. A lot of this is just common sense, but again, administer your Oracle system. The resources and other topics. Questions? Thanks.